Hi, my name is Bill Kinney and I'm a math professor at Bethel University in St. Paul, Minnesota. This is going to be the first of a couple videos in which I go over Bethel's math, Calculus 1 and Precalculus practice exam, a sample exam for you online. Now if you don't go to Bethel, that's fine. You can still get benefit out of this. You can still learn some algebra and precalculus skills that could benefit you for your precalculus or calculus course that you are taking at your school. If you want to find this exam, I'll show you how to do a search for it. Just search Bethel University math placement, and it is the first link that comes up here. We have a placement exam for elementary education majors, but we also have a placement exam, if you go down this page, for pre-calculus or calculus 1, first semester calculus. We've got a bunch of resources on here, including some written resources. And eventually, if you go down here far enough, you'll see that we have a sample exam right here. Sample exam for pre-calc and calc. Here it is. This is the exam we're going to be going over in two parts. This first part is going to be about the section 1, which is the more basic algebra part. The second part is going to be about section 2, which gets more into pre-calculus skills. We do have the solutions to the sample exams here as well, but those are just answers, not reasons, not explanations. And I want to give you brief explanations in this video. Okay? So let's go ahead and take a look at this sample exam. Again, video 1 here is section 1, more of the algebra-focused exam. It does say this test is to be taken without a calculator. Okay, now you should make that attempt, even though you see this very first problem is a percentage problem, which hardly anybody would do without a calculator. You should strive to do it without a calculator because in the first week of class, at Bethel at least, in calculus and precalculus, you'll have to take something similar to this called a skills test, and you'll have to do that without a calculator. And it is possible here. We're not trying to trick you here. The answer to this first question is one of these four answers. Okay, it's not a trick, and you can therefore guess the answer without doing much calculation. But I'll show you can do a calculation as well. I should say that I'm not very skilled with the smartboard. This is pretty much my first time using it, so please forgive me if I make mistakes and you know how to do things better with the smartboard. And one thing is I was not able to open this PDF with smartboard software, so it's not going to work in the most ideal way. My writing is not going to scroll with it, and so I'm going to have to erase, so please forgive that. We'll deal with it though. So let's go ahead and start with this problem. Last year, product had a retail price of $35. That price has decreased 12.3% over the past year. Find this year's price. First thing you should say is, hey, the price decreased. It can't be bigger. That allows me to rule out that one. Okay? Second thing is, when it's a 12.3% decrease as opposed to, say, a 90% decrease, that's a relatively small decrease. It can't be a real low price. So it's got to be one of these two. And maybe you can guess pretty quickly that, in fact, it's got to be this one. Okay? Can you reason it out and be confident? Well, certainly a 10% decrease is easy to figure out. 10% of $35, just move the decimal place to the left one spot, is $3.50. So 35 minus 350, that would be $31.50. The answer's got to be a little less than $31.50, which this is. If you want to be more confident, I will go ahead and show you that you can figure it out with some mental calculations. 10% of $35, I won't bother writing the dollar sign, would be $3.50. Again, move the decimal place to the left one spot. We're after a 12.3% decrease, remember here? Well, what's a 1% decrease? 1% of 35. You'd have to move the decimal to the left 2 spots. That would be 35 cents, or $0.35. So 2% of 35 is going to be double that, 70 cents. Okay, so that's taking care of the 10% plus 2 more percent. What about 0.3%? 0.1% of 35, you'd have to move the decimal to the left 3 spots. That's going to be 0.035. To find 0.3%, multiply that by 3. 0.3% of 35 you multiply that by 3, you'll get, it's a little tricky, 0.105. So if you add up this number, because we're after the 2%, and this number, you'll get the amount off. 350 plus 0.70 is 420, plus another 10 cents, 11 cents, say, is 431 off, not a price of 431, 431 off, or so, or 430, it looks like we rounded. 35 minus 430 is indeed 3070. Okay, so it can be done without a calculator, but we're not trying to trick you, okay? It is going to be one of these 4 answers. Conceptually speaking, you should realize pretty quickly that this is the correct answer. All right, let's move on to the next problem. Okay, here's where my smartboard skills are a problem. Let's see here. I need to select. All right, it's not. There we go. This one is related to the length of a ladder, and the online exam has a picture. I will just draw the picture. A 12-foot long ladder is leaning against the side of a building. The base of the ladder is 6 feet from the base of the building. Approximately how far up the side of the building does the ladder reach? Okay, so again, there is a picture on the actual exam itself. Guess I'm going to have a green color this time. There we go. So we've got the building over here. Hopefully green comes out okay, color-wise on the video. If it doesn't, I'm in trouble. We've got the ground down here. And we've got the ladder leaning against the side of the building. There's your ladder. Hey, there's a right triangle. That should set off alarm bells in your mind. Maybe trigonometry, maybe the Pythagorean theorem. It's going to be one of those things, 2 things that you need. It's a 12-foot long ladder. There's 12. It's in feet. I won't bother writing the units. The base of the ladder is 6 feet from the base of the building. So the base is the bottom of the ladder. It's 6 feet from the bottom of the building. This side has length 6. Approximately how far up the side of the building does the ladder reach? What's the length of that leg of the triangle? This is going to be a Pythagorean theorem problem. Let's call that h for height. The Pythagorean theorem with this right triangle would say h squared plus 6 squared equals 12 squared. The sum of the squares of the lengths of the legs is equal to the square of the hypotenuse, the longest side for a right triangle. We want to solve this for h. H squared will be 12 squared is 144 minus 6 squared, which is 36, and that's going to be 108. Therefore, h is square root of 108, which is going to be, well, a little bit bigger than 10. That can't be the answer. We definitely have enough information to solve the problem. This can't be the answer either. There are going to be some options that say the answer is not given, but that's not what that says. It says not enough information to solve the problem, but we can solve the problem here. It's got to be one of these 2. Yeah, it's got to be this one. B again. Okay, 13 squared, for example, is 169. It's got to be 10.4. You could check it by actually multiplying 10.4 times itself. I will not bore you with those details if you needed to do it by hand. Okay? It's going to be approximately 108 when you go ahead and multiply that out. Not exactly. This is an approximation. All right. Back to scrolling here. Hopefully it scrolls. I don't know if I need to click. Okay. I guess that was good enough. On to problem number 3. There you see option D says not given, so it's possible the answer is not any of these 3 here. Let's go back. Well, let's try blue for some variety. Here we go. Let's blue. Solve for x in this equation. This is a linear equation. You only see x to the first power. The left side can stay as is. You want to simplify the right side. Negative 2 times 4 is negative 8. Negative 2 times negative 3x is positive 6x. And then you have the minus 2. So the negative 2 needs to get distributed through the parentheses. That's called the distributive property. Simplify, combine the like terms, that's 6x minus 10. Isolate x, you could subtract 5x from both sides. That'll get rid of the x on the left side. Also add 10 to both sides. That will get rid of the minus 10 on the right. You'll be left with 13 equals 6x minus 5x is x. The answer's got to be 13, which, oh, lo and behold, is not given. Is that really the right answer? You might feel kind of scared about whether it really is the right answer or not. Now, certainly you could check these three by plugging them in and seeing that they don't work, but that sounds like a lot of work. Let's go ahead and check this thing, plug it into both sides, see if you get the same number. That would be the quickest way to confirm this is the right answer numerically, but therefore D would be the right answer as far as these four options go. So the left-hand side, when I substitute, x equals 13. 13 times 5 is 65, plus 3 is 68. LHS means left-hand side. RHS, you could plug it in 6x minus 10. 6 times 13, that's going to be 78. Minus 10 is 68. It matches. Technically speaking, you really should plug it into the original. Let's go ahead and do that. You know, because you might have made a mistake in your other work. 3 times 13 is 39. 4 minus 39 is negative 35. Negative 35 times negative 2 is positive 70. Minus 2 is 68. These two things match. Therefore, 13 is the true solution of the equation. Therefore, of these four options, the answer is D, not given. By the way, these problems so far, I hope you find them to be fairly easy. And this is meant to help you do well if you are a Bethel student and needing to take this test, or if you're not a Bethel student and needing to take some other test that might be similar to this. But you should realize that just because you can solve these problems doesn't mean you really learn things super well. And in a class like Precalculus or Calculus, you do want to understand things really well as you possibly can. But we are trying to get across the information as fast as possible here. For example, here, even in this problem, in simplifying this expression, you need to understand the reverse of adding fractions. What do we mean by that? When you add two fractions, say 1/3, this is a side calculation, and 1/4, you should remember you need to get a common denominator. If you think about these things in terms of slicing a pie, for example, you need to make sure the pie slices are the same sizes in the two pies before you combine them. Okay? So you need to get a common denominator. In this case, 12. 1/3 is the same as 4/12. 1/4 is the same as 3/12. Now you have a common denominator. The answer is 4 plus 3 over 12, or 7/12. So that's a deep understanding about how fractions work. And now to solve this problem, you need to be able to work backwards. You need to be able to take something like this and realize you can write it like that. And that's what we're doing in a symbolic sense here. We've got a fraction where the numerator is the sum of two things, just like the numerator here is the sum of two things. You can break it apart into two fractions with the same denominator. In this case, 6x squared over 3x plus 3x over 3x, and then simplify. And now you can do some cancellation. 3 divided by 3 is 1. Both of these 3's cancel to leave you 1 over 1 or 1. These x's are the same. We are assuming here implicitly x is non-zero. We're not dividing by 0. Those can cancel. The 6 divided by 3 is a 2. 2 over 1 is 2. Got x squared over x. That's the same as x times x over x. One of the x's can cancel. You can cancel that x with 1 on the top. In the end, when you simplify all this, what do you get? Looks like you get 2x over 1, which is just 2x, plus 1. Okay? And that is option C, and that is the correct answer. Again, technically speaking, x can't be 0 here, because the original thing is undefined when x is 0. You don't want to divide by 0. So this only equals this when x is non-zero, but that's okay. That's an implicit assumption that we're making here. On to the next problem. Simplify the expression -3 times y to the fourth to the third power. What does that equal? The first thing to realize is when you've got the product of two things to a power, you can raise each thing individually to the power. So this is the same as -3 cubed times y to the fourth cubed. Cubed means to the third power. Okay, that's a fundamental property of exponents. You could write it in abstract form like this. A times b to the c power is a to the c times b to the c, and that is really based on what exponentiation means, at least in the case where c, say, is a positive integer like 3. It's simple to understand because this, for example, if c is 3, a times b cubed really means a times b times itself with 3 factors. And then by the commutative property, the order that you multiply these things in doesn't matter. I can rearrange like this and get a cubed times b cubed. This is a times here. Okay? So at least when the power there, the c, which is 3 in this case, is a positive integer like 1, 2, 3, 4, etc., you can use this kind of reasoning if you're forgetting what the property is. Understand it deeply there. -3 cubed means -3 times itself with 3 factors. -3 times -3 times -3. You've got 3 negative signs. The answer is going to be negative. And 3 times 3 times 3 is 27. So this is -27. Here the property is that you multiply the exponents. Y to the fourth cubed is going to be y to the 4 times 3, or y to the 12th. Okay, why? Well, you could reason it out this way. Y to the fourth cubed is y to the fourth times itself with 3 factors, meaning you've got ultimately 12 factors of y. This is the same as y to the 12th, and 12 is 4 times 3, and that's a property that does generalize. So we have -27 times y to the 12th, and that is option A. Okay? So there we go. Let's move on to the next problem. Determine the slope of a line that contains the 2 given points. (12, -3) and 12, 5. Now it's tempting to just go ahead and right away use the formula. I know slope is rise over run. Change in y over change in x. But wait a minute. Think about it here. Make a quick picture. 12, -3 and 12, 5 are on the same vertical line. And the slope of a vertical line is undefined. The run is 0. You'd be dividing by 0 in the formula for the slope. The answer is D. Okay? There will be another problem we do later where we find the slope of a line and it's not undefined. Okay, so I'll show you the details of that later in that problem. The answer here is undefined. Vertical lines have an undefined slope. Not a slope of 0. You shouldn't say no slope. You should say undefined slope. Whoops. Smartboard skills? No, that's not right. Sorry again about my smartboard skills. There we go. All right, find the difference 6 over 8x minus x over 6, if you can't quite see that. 6 over 8x minus x over 6 when x is non-zero. Here we're saying x is non-zero. I don't know why it wasn't said in that other problem. I didn't write this test. Just using it here. Here we're subtracting 2 fractions. You subtract 2 fractions by getting a common denominator. After all, when you subtract something, you're really adding its opposite. So, I want to get a common denominator. One denominator is 8x, one is 6. Multiply those to get a common denominator of 48x. To get a 48x in the bottom of this fraction, multiply the top and the bottom by 6. You got to do it to the top as well so that the fraction is unchanged. So we get 6 times 6 over 8x times 6. That is the same as 6 over 8x because I'm really multiplying by 1. minus x over 6. I got to multiply the bottom by 8x to get 48x in the bottom, but if I do it to the bottom, I've got to do it to the top, so I'm really multiplying by 1, again, in the case where x is non-zero. The common denominator will be 48x. The numerator is going to be this thing minus that thing. 36 minus 8x squared over 48x. Okay, it involves an x squared. Assuming I haven't made a mistake, that's telling you this has got to be the answer right there, C, because that's the only thing involving an x squared, assuming it doesn't cancel, and it will not cancel here because you can't, that's not a property that you can use. You can't cancel that x with one of those, okay? But is it really that? Can I match this with that? Yeah, you can factor out I really could have gotten away with a smaller common denominator. I really could have gotten away with a denominator of 12x, okay? Because I can factor out a 4 out of the top. And when I do so, sorry about the extraneous noise here. What do I get on the top? Well, what do I need to multiply 4 by to get 36? I need to multiply it by 9. 9 times 4 is 36. I need to multiply 4 by negative 2 to get negative 8, so I get a minus 2x squared over 48x. Now that 4 will cancel with the 48 to leave a 12 down there, and we can rearrange the top if we like. This is negative 2x squared plus 9 over 12x. Okay, I really could have simplified this first fraction a little bit. I could have written it as 3 over 4x to start with, and then gotten a common denominator of 12x to see that more easily. Okay, that is the answer, and that is choice C. Oops. Oh, I didn't know I could do that. How about that? What problem are we on now? Uh-oh, I'm in trouble. Oh, that's 7, okay. 8. Which of the following graphs corresponds to a certain linear equation? 2x minus y equals negative 5. There's a couple ways this can be done. Probably the quickest way is to just find quickly the x and y intercepts. To find the x-intercept, set y equal to 0 and solve for x. 2x will equal negative 5. X is going to be negative 5 halves. Negative 2.5. 2.5. The x-intercept has to be negative 2.5. The answer has to be either A or D. For the y-intercept, set x equal to 0 and solve for y. X equals 0, and there you'll get negative y equals negative 5, so y equals 5. The y-intercept is 5. It's got to be this choice A right here. X-intercept of negative 2.5, y-intercept of 5. You can also solve this equation for y as a function of x and then see what the slope and intercept are, y-intercept. You can add y to both sides of this equation and also add 5. You'll get y equals 2x plus 5. Slope has got to be 2, positive 2. The y-intercept's got to be 5. This is, again, the answer. You see the slope is 2 because rise over run is 2. For example, if the run is 2, the rise is 4. 4 over 2 is 2. The slope of that is 2. A is the answer. Section 1 has 15 problems. We're on problem number 9. Simplify this expression, 9x squared y cubed over 12xy to the 4th. 9 divided by 12 is the same as 3 divided by 4. X squared over x is the same as x. Y cubed over y to the 4th is the same as dividing by y. You can make out what that mess is. This is going to be 3x over 4y is what's left over. And that is choice C. Okay? And that is correct. And that's true as long as we're not dividing by 0. In the original expression, neither x nor y is 0. So that was a nice and quick one. This looks pretty quick as well. 10, evaluate the expression 5x squared minus x to the fourth for x equal to negative 2. What that means is I need to substitute. I need to plug it, x equals negative 2, in here and here in place of the x. It's like plugging into a function. That's what it means when it says evaluate the expression. So we get 5 times, use parentheses for emphasis, negative 2 squared, which is going to be a positive 4, minus, yeah, the trickiest thing is being careful about the parentheses here. I want to make a sign error. So this is 5 times 4 is 20, minus negative 2 to the fourth is positive 16. The answer is 4. Okay, choice A. Number 11, we are simplifying an expression. We're not trying to solve for x here. There's no equation to solve. It's just an expression involving x that just needs to be simplified with the distributive property and then combining like terms, which is also technically based on the distributive property. So distribute the 3 through the parentheses here and say the negative 2 through the parentheses here. If you do so, 3 times 5 is 15. 3 times negative x is negative 3x. Negative 2x times 4 is minus 8x. And then negative 2x times negative 5x is plus 20, or excuse me, plus 10 x squared. Combine these like terms, you get 10x squared minus 11x plus 15. And yeah, that does match choice C. Okay? So that is the answer to number 11. We're getting close to the end here of the first video for section 1. 12, simplify the complex, or you might call it a compound fraction. Fractions within fractions here. If it's a little small for you to see, this says 3xy squared over 2. That's the top of the bigger fraction, divided by 6x squared. I'll rewrite it here. 3xy squared over 2 divided by 6x squared. Quickest way to simplify such a thing is to multiply the top and the bottom, in this case by 2, by a common denominator. If this were 6x squared over 4, for example, I'd want to multiply the top and the bottom by 4. Or if it were over 5, I'd want to multiply the top and the bottom by 5 times 2, or 10. Multiply the top and the bottom of this by 2. That's really multiplying the whole expression by 1, so it doesn't change it. These 2's cancel, making the top be 3xy squared. 6x squared times 2 is 12x squared. 3 divided by 12 is 1/4. One of those x's cancels, and the y squared stays as it is. It looks like the answer is y squared over 4x. Yep, there we go, choice A, y squared over 4x. Oh boy, this one doesn't look quite as easy. Add those fractions. They're not numbers, they're expressions involving two variables, x and y. Once again, you've got to get a common denominator. 3 over x minus y plus 3 over x plus y. Multiply x minus y and x plus y to get your common denominator. For the first fraction, I multiply by x plus y over x plus y, so that the fraction stays the same as long as I'm not dividing by 0. For the second one, I multiply by x minus y over x minus y. Okay, and then we are implicitly assuming we're not dividing by 0. Now we have a common denominator. I can now add the numerators. Expand them, 3x plus 3y plus 3x minus 3y. All over, go ahead and multiply that out. FOIL, if you like to think of it that way. First times first is x times x is x squared. Outside times outside is negative xy. Inside times inside is positive xy, which cancels with the negative xy. Last times last is minus y squared. Up on top, the 3y's go away. 3y minus 3y is 0. And the 3x's are like terms that can be combined to give you 6x. 6x over x squared minus y squared. And that is choice D. Okay. Again, section 2, the second video's problems are harder. If you find this kind of thing pretty easy, they get more into pre-calculus skills, including logarithms and trigonometry, for example. For somebody who's going into pre-calculus, we expect them to do well on section 1. And for somebody who's going into calculus 1, we expect them to do well on section 2. Not that you won't make a mistake here and there in the pressure of a test, but overall doing well. Here's the problem that involves calculating the slope, and this time the slope will not be undefined. Find a linear equation containing those points. So let's first find the slope, sometimes called m. Formula being rise over run. Sometimes written as delta y over delta x, change in y over change in x delta. That triangle symbol, the Greek letter delta, means change in. It's just shorthand for that. Standard kind of notation in science and math. You could also write the formula that way. The thing is to be consistent. It doesn't matter which points you call x1, y1 and x2, y2. It doesn't matter as long as you're consistent. Let's go ahead and do this one as the first, this one's the second. So y2 minus y1 is going to be 1 minus 2. And then x2 minus x1 is negative 1 minus 5. Negative 1 minus 5. So this is negative 1 over negative 6. Positive 1/6 is the slope. That tells you it's, that A and B are not the answers, assuming you've done things right. It's got to be either C or D. You could solve for the y-intercept, but you could also just check that these points work in this equation or not. If you plug in x equals 5, for example, 1/6 times 5 plus 7/6 is 5/6 plus 7/6 is 12/6 or 2, which is the second coordinate of that point. So that point satisfies this equation. It is on this line. How about the other point? 1/6 times its x-coordinate of negative 1 plus 7/6 is 7/6 minus 1/6, which is 6/6 or 1, which is the second coordinate of that point. So yes, both of these points are on this line. You could, like I said, also write the equation, say, in this form and plug in either of these points and solve for B, and you should get 7/6 either way. I'd encourage you to try it both ways. Try both of these points plugged into that equation. Solve for B. Either way, you should get 7/6. This is the answer. Okay. Just one more problem for this video. The end of section 1 here. Oh, and it's a system of linear equations. Maybe the hardest problem on this section. Maybe. Maybe not. Determine the point at which these two lines intersect. Okay, these are going to be two lines in the plane. They could be parallel, for all you know ahead of time, so that means they could not intersect at all, or they could be the same line and there's infinitely many solutions, though that's not an option. Or if they're not parallel, they're going to intersect at just one point. They do form a system of equations, and I like to emphasize that by writing this curvy brace here to the side to emphasize they go together. Don't make a mistake in writing them here. 2x minus 3y equals negative 3. Okay? There are a couple different methods you can use. One's called substitution. I could, for example, solve this equation for x. In terms of y, x would be 9 minus 2y. Then I could replace the x there with 9 minus 2y and solve for y, and then go back and solve for x. Or I can use what's called elimination. I could, for example, multiply the top equation, everything on the top, by 2. And the reason that's a good idea is because I notice the bottom has a negative 2x. And therefore, if I add these two equations, the x is going to go away. 2x plus negative 2x is the same as 2x minus 2x. It goes away and becomes a 0. 6y minus 3y is 3y. I'm really adding those. 6y plus negative 3y. 18 plus negative 3 is the same as 18 minus 3 is 15. So y is 5, and then solve for x, for example, with this one. I guess I'm solving for x there anyway. Probably would have been easier to use substitution here. Well, maybe not. It's about the same level of difficulty. Plug in y equals 5 there, and you get 9 minus 2 times 5 is 9 minus 10, or negative 1. So the point looks to be x, y, negative 1, 5. Is that an option? Oh, no, it's not an option. Is this no solution? I think I might have made a mistake here because I thought there was a solution here. Let me check my work here. So x plus 2y equals 9 was the first equation. Negative 2x minus 3y equals negative 3 is the second equation. Multiply the top by 2. There I see my mistake. If you caught that, you get an A plus. No, just kidding. It's not plus 6y, it's plus 4y. And so in fact, y is 5. And that means, excuse me, 15. So x is 9 minus 30. 9 minus 30 is negative 21. The answer is negative 21, 15, and that is an option. Now, I knew that ahead of time because I did this problem ahead of time. I'm glad I made the mistake to illustrate. I make mistakes too. I knew that ahead of time, but what if I didn't know that ahead of time? Could I have checked that my original answer was wrong? Yeah, you could have checked it back in the original system of equations and seen that at least one of them was false when I plugged x equals, I forgot what it was, x equals whatever it was, y was 5 or something, and x was negative 1, I think. At least one of those equations, it wouldn't work. It would not make the equation true, and then I'd know I did something wrong. And so then I'd look as I did for my mistake. Guess I was a little too excited about finishing here to make that mistake at the end, but I think everything else was right. Thanks for watching. You can watch the second video on section 2. It gets into precalculus as well. Thanks.